Hello everyone, welcome to Superstructure Component of Structures 2 course. This is our first session for the superstructure part, week 4. And today we'll go briefly through some of the content of week 4. And if you have any query, please let me know. I see there is no attendees for the session tonight, but hopefully next week many of you can join us. And anyway, if you have any query regarding anything in the course content or the assessment, please post it to the Q&A forum or send it to the course email. Okay, so in this week, we have an introduction for the load and design overview. Okay, so we have introduction and load and design overview. So in this week, we're just introducing the concepts of superstructure and what are the type of loads and how does the design process using the Australian standard works. So you can watch the videos. This video was recorded by Al Sayed, and you can watch the summary of the week content. And in this week, what you need to do, what you need to know, sorry, is have an overview of different type of loads like dead load, life load, wind load, and so on. And the second topic is the design limit states. We have two type of design limit states, serviceability limit state and strength limit states. The third one is load combination. So as you know, we have different type of loads, dead and life and wind and so on. So we need to make combination of the existing load to find what are the critical load combination there. And next, some structure design concepts and what are the procedure of structure design or what are the steps of structure design. And lastly, we have the calculation or brief calculation of dead load and life load using the Australian standard AS 1170.0 and AS 1170.1. So these two standards are mainly for the load combination and dead and life load calculation on the structures. What you need to do is watching the concept summaries for the week and attempt all the learning activities. Review some of the learning resources available, and if any link is broken or you can't access, just to please let us know to update. We have two learning activities, load and design overview and dead load and life load calculation. Please attempt this two activities. And lastly, we have the self-review quiz to check your knowledge and what you have gained through the week content. So under the first topic, load and design overview, we have two videos about that. So you can watch the videos and you can see here we have the resources of this video or the slides that was used to produce the video. And we have also the standards used to find the dead and life load. And here is the link to the standard 1170.0 version 2002. And just a reminder that the access to the standard is now using engineering workbench. So please use the link and try to access the standard. And if you have any issue with that, just let us know. Okay, so now I will just quickly open the file, the slides file. Okay, this one is briefly to introduce the first topic of this week, load and design overview. And I will quickly go through that to have a quick look on it. So what are the type of loads we have on the building or the structure? So we have two main types. Okay. The two main types are gravity load and I just quickly put it here. So the two main types we have are sorry, are gravity load or gravitational load and lateral load. So these are our two main loads. Sorry. Okay, so we have two main types of loads. We have gravitational load or vertical load, and we have also lateral load or horizontal load. So under gravitational load, we have the first type of load is the dead load or permanent load. What is the dead load or permanent load? The dead load or permanent load is the load that doesn't move on the structure system or doesn't or stay stationary on the structure. So this load, dead load, can take the symbol G, and these are permanent load, and the direction of this loads are gravity direction. This weight or this dead load, including the self weight of the structure system, including all the beams, columns, trusses, and so on, and also include all the non-structural elements like flooring, walls, partitions, and fixed equipment. So any load that doesn't move on the structure system is considered as dead or permanent load. The second type of gravitational load is the life loads or imposed loads. Life loads because it doesn't stay on the structure all the time. So it can be there and sometimes cannot be there. The direction of this load also in the gravity direction or gravitational load. So it is vertical load as well. This life load including people, furniture, and moving load, such as moving load on a bridge here, like traffic loads and people load or pedestrian load, and life load in houses like tables for furniture, people, and so on. So the life load value or the life load calculation is depending on the use or the occupancy of the building. The second main type of load is the horizontal load or lateral load. So we have two types of lateral loads. We have wind load and earthquake load. Wind load are the loads that produced by wind on the structure. So in some cases or in some of the walls of the building, it is caused pressure, like the left-hand side, and on the other side, it can cause suction, like the right-hand side. And the second or the other lateral load we have or we can have is the earthquake loads. And in this course, we are mainly focusing on the wind load. So we will not include the earthquake loads in our calculation or our design. Some other loads that you can have a look on, but we are not using in our course is the soil load or the lateral soil pressure, like on this retaining wall, and we have some fill here. Another one, we have wave loads. This some offshore oil platform. So some of the loads that applied or applicable on this structure is wave load. We have also water load, like in water tanks. So we have also lateral uh, loads on the walls. And we have also impact load. Impact load, like similar to the load from the train wheels on the train line. And you have also some blast load or explosive load due to explosions. So these are some different type of loads you can have a look on. And then the next is the design design procedure or design levels. In the standard, this is named as limit states. So the limit states, we have two type of limit state. We have ultimate or strength limit states, and we have serviceability limit state. Ultimate limit state deal with the building or the structure element at its failure. So we are investigating the strength of the element at its failure. So we need to make sure that the structure is strong enough to carry the loads. So this is how the design works. So we need to make sure that the structure will sustain all the loads expected to be applied to it. Another design criteria, the serviceability limit states. The serviceability limit states deal with the structure under the existing load, the normal or the the working load, not at failure. So this is the main difference between the two design criteria. One, which is the strength, deal with the structure at its failure. The other is serviceability, which deals with the structure under the working load. The serviceability means we need to make sure that the stiffness of the structure is good enough to sustain the load. So we under the serviceability we are checking some deformation of the structure like deflection, vibration, drifting, and so on. So we have two criteria of design. We need to satisfy both to make a safe and economic design. So these are some example of the serviceability. Like here we have some cracks in the roof board due to excessive deflection of the roof. Here as well we have also some cracks in the walls and also sagging of the floor or the beam due to like problem in the foundation here as you can see. Also here we have vibration due to some sensitive machinery. So we need to make sure that this vibration will not cause any failure or any problem in the structure. Here we have also gears stop working due to like expansion or detraction of the gears. So this excessive deformation can also be like causing like similar to the first one is excessive deformation cracking, sorry, it's cause plaster cracking. So you can see the cracking, the roof plaster is cracked, and also can cause problem in closing doors and so on. So we need to avoid these deformations. Also, if the slabs, like if we have vibration in the slab due to the machinery, so the people will feel unsafe under this slab. Okay, so this is just a summary of the serviceability and ultimate limit state. So serviceability limit state is concerns about the compliance with the limits of deflection, sway, excessive displacement, and vibration. So we need to make sure that the deflection and other deformation of the structure is less than the allowable limits. For the strength, the aspect is the resistance against collapse or failure. So there are two different design criteria for our design procedures. The next part is the load combination. The load combination can be found in the Australian Standard 1170.0 version 2002. So as we learned it earlier, we have some different type of dead load, some different type of load. We have dead load, life load, and we have wind load, and we have earthquake load. So as you may know, not all the loads will be existing on the structure at the same time. That's why we need to make some load combination to see what is the critical or what is the highest load can be applicable on the structure. So that's why the standard give us several load combination, like 6 load combination. We need to calculate all of them and pick the critical or the highest one. So the first one is dead load only. So in the dead load only, we have 1.35 G. So this is the ultimate or strength limit state. So in the strength limit states, the standard try to expect more load than the the actual load. So instead of only considering G, they considered increased G with 35%, so it is 1.35 G. If we have dead load and live load, we have 1.2 of G, the dead load, and 1.5 of the live load Q. If we have dead load and live load for loads that stay for long term on the building, and for some cases like timber, when the long-term loading cause some other problem like creeping and shrinkage and so on. So we have 1.2 G plus 1.5 epsi L Q. So this factor is to account for the long-term application of the load. Another one is dead load. If we have combination of dead load, live load, and wind load, so we have 1.2 of G psi c of q and wu. Wu is the ultimate wind load, u for ultimate. Psi c is similar to psi l, but l for long term and psi c for combination or combined. So this is the fourth one. The fifth one or the next one is dead load and wind load reversal. The wind load can be applied in two directions. One of them is pushing the element or into the element, so this called compression. And the other one is pulling the element or suction of the element. So it is getting out of the away of the element. So it is called suction. So we have another direction of the wind load, which is reversal. So the first one is the normal wind downward. The second one or the next one is the wind load reversal, means wind the load acting upward. So if the wind load acting upward, we have 0.9 of G plus WU. The last one, which is not very important in our course, but to know it, we have, if we have dead load and live load and earthquake load, so we have G plus EU, the earthquake load, plus psi EQ. So we have three component: dead load, earthquake, and live load. Here is explanation of the parameters. We have psi L and psi C, depending on the structure, ranging between 0.4 and 0.6, and maximum of 1 to 1.2 for machinery is installed for long term. All this factor can be found in table 4.1 in the Stirling Standard 1170.0. So you don't have to keep in mind any of these values, but you need to know how to find it, how to find them in the Stirling Standard. Okay, so the last one, the last page was the strength limit states. Here we have the serviceability limit state. In the serviceability limit state, we have also some combination of the applicable load like dead load, live load, wind load. But here the difference is dead load, and if we have dead load and live load, so we have G plus psi SQ. So as you can see, there is no magnification factor before G or no magnification factor before Q, because the loads here are the actual working load, not magnified load similar to the strength limit states. Okay, the next one is dead load life load, long-term life load. So we have G plus psi L Q. So the first one, psi S, means short term. The second one, psi L, means long term. If we have dead load, life load, and wind load, so we have G, psi S Q, and WS. Here, WS means wind for serviceability. The previous one was was WU, means ultimate wind. Okay, so this was the load combination for strength limit state and for self-stability limit state can be found in the Australian standard 1170.0. The next is how do engineers design? How the design work? So the design work, we need to make a balance between safety and economical design. So you can make safe design, like put the biggest section or the biggest cross section for any element, which will be safe, but it will not be economic. So our rule is to make the design safe, make a balance between safe and economic design to save the money for the owner and also make sure that the tenants or the user of the buildings are safe. So this is the main rule in design, make this balance. So to make this balance, we have this formula here or this criteria of design here. So this criteria for the ultimate limit state design. So we have two sides of the balance. The left-hand side is asterisk, means the applied load or the critical design action effect. So this what is applied to the building. The right-hand side is the strength or the ability of the building or the structure to resist the load. So we have applied load and resistance. So if the resistance more than the applied load, this section or this structure will be safe. If they are close, so this means safe and economic. If this right hand side is too high compared to this, the design is safe, but it is ineconomic. This is what is meant here. So we need to make the balance between S asterisk and phi RU, where S asterisk is the critical design action effect that can be calculated using the ultimate limit state load combination 1.3G, 1.2G plus 1.5Q, and so on. The right hand side is the nominal resistance of the component obtained using the code formulas. In short words, it is the maximum resistance of the structure. Okay, phi and these values can be also calculated or found in the design capacity tables of the cross sections that will be accessed in the or can be found in the available resources of the course. Phi is just a reduction factor just to make some safety factor in the design. So we know that, for example, the resistance of this structure is 1000, but we will only consider it as, for example, 600 just to make a safety margin for the designer. So as you can see, the capacity reduction factor ranging between 0.6 to 0.95 based on the type of the action or the loads on the element and so on. This can be found in the Australian standard for steel design AS 4100. Okay. Okay, so this was for ultimate limit state, and now for the serviceability limit state, we have also again a balance. We need to make the balance between two values. The value to the left is the maximum deflection or deformation obtained using the load combination for serviceability, G plus psi SQ, G plus psi LQ, and so on. So this is the deflection from the applied load. This one, psi t, is the allowable limit states, or sorry, allowable limits of deflection or vibration by the Australian standard. So the standard give us a limits for the deflection for each type of element that cannot be exceeded to make a safe design. So if the deflection of the element less than the allowable limit. So this means that the design is safe for serviceability and you can continue of your design process. Okay, so this like short or brief example of design of this truss type. So as you can see, and this is steps of design. So as you can see, we have a truss and we need to design the element of this truss. So the first step is the calculation of the structure system. As you can see, similar to what you have done in structure 1, for example, we have B1 and B2 like 150 and 75 and so on. So this is the first step. The second step is to calculate or make a structure analysis to find the reactions and the forces in the members and connection. So this is the next step. Find the reaction at A and C, for example. Find the forces in member AB, BE, BD, AD, and so on. After you find the forces, you need to make load combination for strength and serviceability limit state, similar to what we have illustrated earlier. The next step after load combination is the design for ultimate limit state. So we have S asterisk should be less than or equal to phi RU. So we have the demand less than the capacity. After you design for ultimate limit state, you need to check for serviceability. So you need to make sure that delta less than delta T. After that, after you finish the design and make sure the design is safe and economic, you can make a cost analysis of the selected member or selected design. Okay. Okay, that's it for the loads and design procedure. And hopefully you can understand this short discussion. And please let us know if you have any query about it. Please go through the weekly content, week 4 content, and go through the activities and let us know if you have any query. Thank you and have a good night.